Have you ever wondered how binary data is inputted and displayed in assembly language programming? Binary data, the zeros and ones that form the basis of all digital information, is the raw material that assembly language uses to interact with hardware and carry out operations. In the world of assembly language programming, procedures for inputting and displaying this binary data are critical. These procedures often involve interactions with input and output devices, or even system calls, to read and write binary values. The specific implementation of these procedures can vary widely, depending on the platform and the environment in which the assembly code is running. Regardless, understanding these procedures is a fundamental part of mastering assembly language programming. So, are you ready to plunge into the world of binary data in assembly language? Let's dive into the procedures for inputting and displaying binary data in assembly programming. First, we'll explore the procedure for inputting binary data. This process, although it may seem complex, can be broken down into 3 manageable steps: reading binary input, converting binary to decimal, and storing binary data. Step 1 involves reading the binary input. This is achieved by using system-specific input functions or interrupt calls to read the binary input from a source. It could be from a keyboard, a file, or even user input. The specifics of this process can vary greatly depending on the environment in which your assembly code is running. The second step is where we convert the binary input to decimal. If the input is provided as a binary string, it needs to be converted to a decimal representation for internal processing. This is an important step as it allows for easier manipulation and processing of the data within the program. Finally, the third step is to store the binary data. This involves storing the binary data in memory for further processing or manipulation. This data can be retrieved and used later as needed within your program. Now let's consider a simplified example in x86 assembly language using DOS interrupts for reading binary input. We start by setting up a buffer to store our binary input. Then, we use a DOS interrupt to read the character input and store it in our buffer. Next, we would convert the binary to decimal and process the data. The specifics of this conversion and further processing would depend on the requirements of your program. Lastly, we use another DOS interrupt to terminate the program. Remember, this is a simplified example, and the actual implementation can vary based on the specific requirements of your program and the assembly language being used. Now that we've covered inputting binary data, let's move on to how we display it. This will involve converting the internal representation of the binary data to its binary form for display, and then using system-specific output functions or interrupts to display the binary data. But more on that in the next scene. Stay tuned. So, how do we display binary data in assembly language programming? Now that we have our binary input, it's time to showcase it to the world. This process involves 2 main steps: converting our decimal representation back to binary and displaying this binary data. Let's begin with the conversion. Suppose we have a decimal value stored in our system as our binary data. To display this data, we must convert it back to its original binary form. This conversion is essential because while our system processes data in decimal format, we humans often find binary or hexadecimal formats easier to interpret when dealing with low-level programming. Now, on to the second step: displaying the binary data. To do this, we use system-specific output functions or interrupts. One thing to note is that this process might involve converting our binary digits to ASCII characters for display. This conversion ensures that our binary data is displayed in a format that is recognizable and readable. Let's take a look at a simplified example. Suppose we're working with x86 assembly language and DOS interrupts. We have a binary value in decimal representation stored in our system. Our task is to convert this back to binary and display it. We would do this by implementing a conversion and display procedure that suits our specific requirements. After our binary data is ready for the spotlight, we terminate the program. In our DOS environment, we do this by moving the DOS function code for program termination into the A register and calling the DOS interrupt. And voila! Our binary data is out in the open, ready for any observer to see. Remember, this is a simplified example, and actual implementation can vary greatly depending on the specific requirements and the capabilities of the assembly language being used. With that, we've covered the basics of displaying binary data. Now, let's look at some important notes. There are some important points to remember when working with binary data in assembly language programming. Firstly, the actual implementation of converting binary to decimal and vice versa is not set in stone. It depends on the specific requirements of your program and the capabilities of the assembly language you're using. So, while our examples provide a basic understanding, you'll need to tailor your approach based on your unique circumstances. Secondly, when it comes to more complex input and output operations, you might need to bring in the big guns. By this, we mean higher-level libraries or operating system functions. These tools can help you handle operations that are too intricate or cumbersome to manage with basic assembly language. On a related note, modern assembly languages aren't identical twins. They have different conventions for system calls and input-output operations. Our examples are simplified for illustrative purposes, based on the x86 assembly language and DOS interrupts. If you're working with a different assembly language or environment, you'll need to adjust accordingly. Lastly, it's crucial to remember that these procedures only provide a general framework. They're not a one-size-fits-all solution. The specifics of the implementation would depend on the requirements of your program and the capabilities of the assembly language and platform you're working with. In other words, there's a lot of room for customization and flexibility. It's like cooking a recipe. You have basic instructions and ingredients, but the final taste depends on your personal touch and the quality of your ingredients. So, as you navigate this world of binary data procedures in assembly language, remember to stay adaptable. Make use of the resources available to you, from higher-level libraries to different assembly language conventions. And most importantly, don't be afraid to experiment and make adjustments to fit your needs. These notes should help you navigate the challenges of implementing binary data procedures in different environments. Let's recap what we've learned about handling binary data in assembly language programming. We delved into the intricate procedures of inputting and displaying binary data, which are critical operations when you're working with assembly language programming. We started with the procedure for inputting binary data. This involves using system-specific input functions or interrupt calls to read binary input from a variety of sources, such as a keyboard, a file, or user input. If the input is provided as a binary string, it's converted to a decimal representation for internal processing. This binary data is then stored in memory for further processing or manipulation. We demonstrated this with a simplified x86 assembly language example using DOS interrupts for reading binary input. We then moved on to the displayBinary procedure. This is the process of converting the internal representation of the binary data, such as a decimal value, back to its binary form for display. System-specific output functions or interrupts are used to display the binary data, which may involve converting binary digits to ASCII characters for display. Again, we provided an example in x86 assembly language using DOS interrupts for displaying binary output. Throughout our discussion, we emphasized that the specific implementation of these procedures can vary greatly. This is dependent on the platform and the environment in which the assembly code is running. Whether it's a different assembly language, a different operating system, or a different set of requirements, adjustments may be needed to suit the particular circumstances. We also pointed out that for more complex input and output operations, it might be necessary to use higher-level libraries or operating system functions. The conversion of binary to decimal and vice versa, as well as the implementation of further processing, depends on the specific requirements and the capabilities of the assembly language being used. The procedures we have discussed provide a general framework. The specifics of the implementation would depend on the requirements of the program and the capabilities of the assembly language and platform being used. It's always important to remember that while these examples are simplified and based on x86 assembly language and DOS interrupts for illustrative purposes, modern assembly languages may have different conventions for system calls and input-output operations. In conclusion, handling binary data in assembly language programming requires a clear understanding of the procedures for inputting and displaying binary data, the variability of implementations, and the need for adjustments based on the assembly language and environment. Thank you for joining me in this exploration of binary data in assembly language programming. I hope you found it informative and helpful in your coding journey.